Hello everyone, and welcome back to the channel. Today we're diving into the topic of number systems. What is a number system? It is a way of representing numbers with digits or symbols, and you have been using one your entire life, and maybe without even realizing it. There is way more than one way to represent how to count though. Let's start with the number system we're all familiar with, base 10, or the decimal system. An easy way to remember that the decimal system represents base 10 is to think of a word you may be more familiar with, like decade, which means 10 years. Why do we use base 10 by default? Well, a lot of it likely has to do with something physical, our fingers. We have 10 fingers, so it makes sense that counting in groups of 10 feels natural to us as humans. In base 10, we have 10 digits to work with, 0 through 9. Each place in a number represents a power of 10. For example, in the number 573, the 5 is in the hundredths place, the 7 is in the tens place, and the 3 is in the ones place. By adding these numbers together, we get 573. But here's the twist. Base 10 isn't the only way to represent numbers. Imagine you only had 2 fingers, or 4, or even 16. Other cultures in modern day computing use entirely different systems. The rise of computers has been a popular catalyst in learning these different bases, especially base 2. When you think about it, computers essentially only have 2 fingers to count with. Electricity flowing in or no electricity. This is called the binary system, or base 2, and this is the backbone of computing. In binary, you only have 2 digits, 0 and 1. Each place represents a power of 2 instead of 10. So the binary number 1011 equals 11 in base 10. There are 2 more popular bases made popular by computing. Base 8 or octal. Here you have digits 0 through 7 to represent the number. There's also base 16 or hexadecimal. This system uses 16 symbols. So instead of only using the digits 0 through 9, we also have to represent 10 through 15, and we do that using the letters A through F. These are not the only bases. Other bases exist too, like base 12, which shows up in old measurement systems, or even base 60, which we still use to measure time. In fact, you can literally use any base you want in a number system. There may not be a practical reason to do so, but it can be done. We will now look at a program I wrote that will visualize the steps of converting a base 10 number into any other base using the technique called successive division. The application that I made, and this is just a simple application I made to kind of simulate converting from a base 10 to any other base, and this will step us through the algorithm to do this. So we could pick some random number. So on this, you just enter the number that you start with and then the new base that you want it represented in. So in this case, let's do the number 28 in base 10 and convert it to base 2. Okay, so the way the algorithm works is we take the current number, we divide it by the new base, and we keep track of the remainder, and then the number that we divided it by, the new number, we're going to divide that again by the new base, and we're just going to continue to do this while we keep track of the remainder. So here it is, number 28, we divide it by 2, and the remainder is going to be 0 because 2 is equally divided into 28 by 2. Then we go to 14, divided by 2, keep track of the remainder, which is 0. That leaves us 7, we divide it by 2, and the remainder is 1. That leaves us 3, divide that by 2, and the remainder is 1. Then we have 1, and we divide it by 2, and obviously the remainder is 1. So we basically reverse the order. So the most significant bit is going to be the last divided remainder, and then the least significant bit, which is 0, which is from here, is going to be the first remainder that we have. So the number 28 in base 10 is equivalent to 11100 in base 2. Now if we restart this, and let's maybe try a number, let's try maybe number 170, and let's try changing it to base 16, which is another popular base. All right, so we'll go through the algorithm again. We start with 170, we divide it by 16, and we get a remainder of 10. Now we have 10, and we divide it by 16, and we get a remainder of 10. Now, for base 16, we have 0 through 9 as digits that we could use, and then we basically need to represent 16 total numbers, essentially. So in this case, we had a remainder of 10, but since we're already using 1 and 0 as a symbol to represent this number, we need a different way to represent 10. So we use the letter A to represent 10. So this is basically 1010 in base 16, or we could say AA in base 16. So the number 170 in base 10 is equal to AA in base 16. Now we could essentially do this with, any base, but for example, if we put 200 here, I didn't have enough symbols to represent this. So basically, even though 200 is a valid base, there's just not enough symbols to represent this. So I just went through the alphabet as my symbols. So I think maybe we could get up to like maybe 40. Yeah, so this is a valid base, and then 28 divided by 40, obviously the remainder is going to be 28, but let's see how that's represented in base 40 in the way that I have it set up. 28 divided by 40, the remainder is going to be 28, and that's represented with an S. Traditionally, you're not going to see these types of bases. Normally, they go up to 16, and that's about really all that we see out in the world that's usable. But there's nothing stopping us from using literally any base. We can use up to n bases. Maybe let's look at one more other popular one, and that is base 8, or octal. And why don't we set this to some random number. So the number 2457 in base 10, we'll let this algorithm calculate it for us. The least significant number is going to be 1. So far we have 631. There's still more to do, and here's the final number. So 2457 base 10 is equivalent to 4631 in base 8. And yeah, that basically showcases this algorithm, how to convert from base 10 to any other base. And I'll share a link to this application on my website if you want to play around with it and figure out what's happening and how to do these conversions yourself. Thank you.